Alrighty, so let's get going with writing our test. So I'm going to delete this invalid test here that I just wanted to have so it failed. And then I'm going to add, our scalar is fine. Scalars are simple. Like I said, it's only one line of code here, so I'm not going to think that that's going to fail. Let's test our arrays. So in array, I want to say throws on invalid type is going to be the first test. And what I'm going to do is say expect, and I'm going to pass in a function. I'm going to say makeDiff on woe to an array. I'm going to say .toThrow. So if I tried to make a diff with a before of a string and an after of an array, I want it to throw an exception. So let's go ahead and implement that. I'm wondering, no, I can probably just hide this so we can have our test on the right and our diff on the left here. And move this over here. So for the makeDiff array, the first thing that we want to do is say if before does not equal null and not is array before, then throw new error. And I'm going to use a template string and say location colon, you can't change the type of a value. Now all of our tests pass. So now let's continue on making more tests. So I want to say unchanged on empty. Unchanged on empty will start a empty array and have after an empty array, and then it should be is unchanged. So right now that test passes because we're just returning is unchanged all the time. Next up, I want to write a test for empties array. And with this test, whoops, why did I do that? That's madness. In this test, what I'm going to do is I'm going to start off with an array of 1, 2, and 3. Then the after is going to be an empty array. Now the result of this is going to be an object that's going to say splice, and it's going to say 0, 3. So the result of this diff, of taking an array that has values in it and emptying it out, should result in a splice operation that says clear out everything in the array. And of course now we're getting a failure because we haven't implemented that yet. So what I'm going to do now is I'm going to implement that. So I'm going to say, first of all, I'm going to add in a check. If before is null, always return after. Then I'm going to say if after.length is 0, then return before and before.length. Question mark. I'm going to break this out and clean up the code just a little bit. Question mark, and then I'm going to pass in our splice. So if our before and our after, or if our after at length is 0, but our before has a length, then we want to return an operation that says splice the array from 0 to before.length. Otherwise, return is unchanged. And now all of our tests pass. So now we want to do some other simple array tests. So I'm going to add another test for, I'm going to do another category called simple, which will be an object. And under simple, we'll do unchanged. And unchanged will have a 1, 2, a 3. And the after will have a 1, 2, and 3. And the result I want is unchanged. Now that's going to still pass because, again, we're always returning is unchanged. Now let's do a splice. Now, I've already written this test, so I've done the math already. But let's go ahead and do a splice, a simple splice. The before will be 1, 2, and 3. The after will be 1, 2, 4, 5. And the resulting operation should be a splice operation that invokes 3, 1, 4, 5. Now, what does the splice of 3, 1, 4, 5 mean? That means start on the third index, delete one item, and then add 4 and 5 to the end. So this operation, when applied, when merged, will take this value and turn it into this value. So as you see, we get an error. So now we have to start working on how we're going to properly splice things. So after we check to see if the after length is 0, I'm going to say if not after at 0 has own property ID. So if the items do not have a value called ID, then we're going to do a very simple sort of splice algorithm. And I'm just going to write it out. Because it might not, this diffing algorithm might not be the most efficient. There's probably ways to make it even more efficient. It's not the worst in the world, but I just went with what worked, honestly. So to implement splicing, I'm going to say const result equals empty array. Let splice begin equals -1. Let splice add equals array. Then I'm going to say for let I equals 0, I smaller than after length I++. Then I'm going to grab the item that we're looking at in the after. Then I'm going to say if I is greater or equal to before.length, meaning if we pass the length of the before array, meaning items were added, then I'm going to say if splice begin is -1, then splice begin is now I. Then I'm going to say splice add push item and then continue. So what we're doing is we're saying, okay, so we've passed the before array already. There's nothing more to compare with the before. If we haven't already started splicing, start splicing here, and then whether or not we've already started splicing, add the item to add at the splice add. Then I'm going to say, if splice begin does not equal -1, then splice add push item. So this means if we've started splicing already, if we're starting cutting off the before array, then add it to splice add. And then we want to simply continue. We don't want to do any more results. Okay, now is where things get interesting. Now we know that we haven't yet reached the end of the before array. We know that we haven't yet found a difference. So now we have to recursively invoke makeDiff to see if the item that we're looking at the index of the after array is the same as the item that we're looking at in the instance of the before array. So we'll say const result equals makeDiff, passing in before at I, item for the after, and then for the location, I'm going to do dot, our location, at, and then I. So you'll notice I'm recursively constructing a location string to help with debugging. Now, it might add a little bit of a performance hit, so you might want to consider maybe removing that for production builds. Then I'm going to say if result does not equal is unchanged, meaning the item has changed. Then I'm going to say if splice begin equals -1, splice begin equals I, meaning now we found a change, we want to start our splice at this point, and then we want to say splice add push item. All right, so far it's still not going to work because we haven't returned anything yet. So outside of the for loop, I'm going to say let splice count equals before length minus splice begin. And then if splice begin is -1, meaning we haven't yet started a splice, and after length is smaller than before length, this means items were removed. Then splice begin equals after length, and splice count equals before.length minus after.length. This means we reached the end of looping over our after items. We didn't find any changes, but for some reason the after array is smaller than the before array, meaning we now have to chop off the end of that before array. Then I'm going to say return splice begins equals -1, question mark is unchanged. If splice begins is -1 by this point, if it hasn't yet been set to one of the indices inside of before, then it's completely unchanged. Otherwise, we'll return a splice operation, which will begin at splice begin. It'll go splice count items away to delete, and then it'll add splice add. So we're saying start slicing here, delete this many items, and then add these items. All right, let's. I'm going to bring this off the screen so that I can bring it over the next time we do that. Okay, so we have one failure. The simple splice is still failing, and if I expand my my console a little bit, I should be able to better see what is happening. So it's expecting object 2145 to equal 3145. So it looks like we have an off by 1 error somewhere, which is the bane of every programmer's existence, especially when doing algorithmic work such as this. Actually, remember when I said I already did the math in my head or on paper? I lied. It actually is supposed to be 2145. We start at index 2, which is the third item. Okay, now all of our tests are passing. So let's write some more tests. Let's see what happens if we add one item to the end. So add one at end. And the before is going to be 1 and 2 and 3. The after is going to be 1, 2, 3, 4. And the diff I expect is a splice starting at 3, deleting 0 items, and then adding the item 4. And that test is passing just fine. Let's do remove 1 at end. 1, 2, 3, followed by an array of 1 and 2, followed by a splice. So removing 1 at end should have a splice of 2 and 1, meaning go to the second item, or whoops, am I stupid? 1, 2, 3, 1, 2. I don't know what I did there. Oh, I am stupid. I've been prefixing all of my operations with a money symbol. Okay, so yeah, let's remove 1 in the middle. So this is 1, 2, 3, and then we'll do an array of an after of 1 and 3, and then the diff should be a splice of, well, 1, 2, 3, which this means basically go past the first item, delete 2 items, and then insert a third one. So this actual part of the algorithm can be made more efficient. Removing an item in the middle could be made more efficient, but I wanted to keep the diff algorithm as simple as possible. But yeah. Now let's do complex arrays. Now these are, like the name suggests, a little bit more complex. Complex arrays are for arrays that items have IDs in them. And we're going to be handling this in a very different way. So let's start with unchanged. In unchanged, we'll start with an array of an item with an ID of 1 and a text of old. Let's just do 3 items. Old, whoa, hey. And an ID of 2 and an ID of 3. That'll be the before. And the after is, I'm just going to copy and paste this because the after will be the same. And then I want it to result in is unchanged. And this test should pass because currently we're returning is unchanged if the after has a own property of ID. Actually, I don't know why I had result here. Let's remove that. Okay, so let's go ahead and do another one, a more complex one. A more complex operation, let's do removes 1. Will be something like, we'll have an array with an ID of 1 and a text of hey, followed by an ID of 2 and a text of whoa. So that'll be the before, that'll be the after, or no, that'll be the before. The after, we're going to remove the second item. Now this is where things get interesting. For complex arrays, I'm not going to return a splice operation because those would be woefully inefficient. Instead, I'm going to return a special thing called an update. And we'll have an update, which will be an empty object in this case because nothing was updated. And then we'll have an IDs. And the IDs in this case will simply contain 1. In a complex update, we will have this update command, which will contain all updated values on the object, on the array rather, followed by a list of all the IDs, an array of all the IDs. And the IDs will be in order. And this way, the IDs will allow us to reorder things. In fact, let's go ahead and do a reorder. So let's say removes 1, let's change this to reorder, where in the second array, the after array, I put the ID of 2 after the ID of 1. Now the result of this operation should have no update, but the IDs should be 2 followed by 1. Now let's go ahead and do a simple update. I'm not going to write all the tests that I had before, but I'm going to write the main ones. Let's do an update. I'm going to copy and paste the before and after to be the same, except in the second case, I'm going to set to hey and whoa instead of hey. So in this result, what I'm expecting is the IDs to be 1 and 2 because the order didn't change. But on update, I want the key of 2 to now have a text of hey and whoa. Now, this isn't going to work quite yet because we have to implement our merge object first. But this will give us enough to work with. So let's go ahead and implement the complex arrays if they do have a property called ID. So let's scroll down to the bottom and say else. And this is going to be a slightly inefficient algorithm, but mostly just for the purposes of being speedy. Also, for smaller views, it won't matter as much, but that's okay. What I'm going to do is I'm going to say let items before equals null empty object. Otherwise, before.reduce object item goes into, and then I'm going to start off the reduce with an empty object, and then I'm going to say object item.id equals item, and we say return object. So what does this do? This loops through all of the items in the before array. Well, if the before is null, it just returns an empty object. But if it's not null, it loops through all of the items in the before array and creates a new object called items before that will go ahead and contain all of the IDs with the items. So it'll take an array like ID1 text whoa and turn it into an object with one ID1 text whoa. All right. So then what I want to do is I want to say const ID order equals array, const mutated items equals object, let mutated count equals 0, let same count equals 0. Then I'm going to say for let I equals 0, I smaller than after length I plus plus. Then I'm going to say let item after equals after at I. Then I'm going to say ID order push item after dot ID. So I'm keeping track of the ID order of all of the after items. Then I'm going to say if before does not equal null and I is smaller than before dot length and before at I dot ID equals item after dot ID, then same count plus plus. That means nothing changed. Or rather, it means the order of that item didn't change. Then I'm going to say let item before equals items before item after dot ID. So now what I'm doing is I'm getting the item as it existed before by referencing the items before hash or object. Then I'm going to say const result equals makeDiff on item before item after, and then followed by my location at I, just for debugging purposes. Then I'm going to say if result equals is unchanged, then return, or not return, continue. Then delete result.id. So delete the ID key out of the result, because we don't need that. Then I'm going to say mutated items, item after ID equals result, and then mutated count plus plus. Okay, that's the basic algorithm. So take a look at that, because I got to scroll down. Now I'm going to say if same count equals after length and mutated count equals 0 and before length equals after length, basically, if nothing changed, then returned is unchanged. Otherwise, return same count equals after dot length and before length equals after dot length, meaning that we don't have the same count is the items that are the same ID every time. So if same count is after length and before length is after length, that means that that items were mutated, but they didn't change order. So we only have to pass in an update with the mutated items. Otherwise, we need to pass in an update with the mutated items as well as the IDs, which is an ID order. So that'll handle reordering things. And I can delete this return is unchanged because that's actually unreachable code. Anyway, we'll stop this video here. The tests are now passing. So take a look at this code real fast. And that's all we added in this video. Well, actually, we also added the splice, didn't we? And that is the implementation of diffing an array. And with that, we'll see you guys in the next video. Well, remember, the one test that is not passing is the one where I updated an object, and that's because we haven't implemented object diffing yet. But with that, we'll see you guys later.